All right, everyone. What we are going to do is get to a point. What? Okay. We're going to get to a point where the building kind of feels a little bit more complete. Okay. Right now, what we've generated is a structural system that isn't really working, but we're also going to build a facade that's going to relate to the floors themselves, and we're going to sort of build some framework and start to look at it as an actual building system. Okay, so I might even graft in some simple louvers and stuff like that. I'm not going to make it too complex yet, but it should be something that feels real. So first and foremost, I think one of the things that throws me off about this building is that structurally it's a little weird, right? We have these sort of tilting, twisting structural columns, and there's nothing holding them up except the diaphragm of the floors, which would just twist and crunch if you were to ever put any compression on it. So yeah, when you're doing these kind of quadrahelical things, that's what's going to happen. But anyway, what we need to do for that is actually incredibly simple. We need to take one edge from each of the surfaces that we originally generated, and I'm just going to very simply in schematic create a tapered column that's going to just warp up with the building and provide some resistance for each of these systems. And so these base facades, that would be those right there, each of them has an edge that I want. So just like we did with this system down here, I'm going to move that over there for reference, and I'm going to copy all those.
Do you want to show us?
Oh, shoot. That's right, I'm on the other screen. I forgot you don't have two screens. So these facades are... Sorry, guys. These facades right here, let me fix my screen, are the ones that I'm interested in. They're all the way back in the beginning. And I just made a copy of these right here. So these were the ones that I plugged into the structural system. Okay, I'm making a copy so I can move it somewhere else and make it a clean idea. So copy and paste that, and then we can put it somewhere else in the file. Shoot. All right, I'll move these ones over here. So I'm starting a new idea. So with each one of these, I need to find a particular edge, and I'm just going to do a surface deconstruct brep, and I'm going to plug in this one here, and I'm going to do a set list item on the edges and make sure that I grab one of the edges. Okay, this is going to take a little bit of coordination because I need to make sure I grab the right edge for each surface. So slider from 0 to 3, since it is a quadrilateral. Plug that in there. And grab one of your edges like that. Clear enough so far? Pretty straightforward. This is easy compared to what we did yesterday, or last class. Yeah, it did get a little crazy, huh? So anyway, I'm going to copy and paste this onto each one. The reason I'm using copy and paste and not trying to gang them up together is because it might be a little easier for me to control. And since the geometry isn't too crazy, I think I can handle this. So I grab this one, so that was that edge. This one grabs that edge, and I'm just going to keep copying this down. Theoretically, it should be a list item of index 1 for all of my surfaces, but you just want to double check that it's going to work properly. So that's that one, and then I'll do another one down here for that. Okay, so they're all working properly. Since they're all working properly, I could make them all the right slider of just one slider with the number 1 and plug it into each one, but since I'm already done, I'm not going to bother. Okay, this system should work out fine the way it is. One thing that I am going to do here is I'm actually going to create a pipe with a variable diameter, and that's just going to be a cylindrical tapered column that's going to support this thing. So under surface and freeform, I'm going to do pipe variable. And with this pipe variable, I'm just going to plug in all of the curves that I'm going to use by holding shift and just drop them all on there. And I don't think all of you used pipe variable yet, right? Only a couple of you used it for your bridge, if I'm correct, right? So I need to kind of explain how it works. So T is a parameter. And by parameter, you guys know what I mean by that, right? Can any of you guys tell me what that means in this case? Anyone know what a curve parameter is? Okay, you guys need to start learning the terminology. Okay, curve, whenever I'm talking about a parameter, it's of a linear element or a magnitude element, or, well, yeah, I guess a linear element. It's going to fall somewhere as a percentage or magnitude within a certain range. Okay, so when you're saying a curve parameter, that means what percentage of position along the length of this curve or magnitude along the length of this curve am I going to place a datum point? Does that make sense? So a parameter of 0 would be the start point of the curve. A parameter of 1 would be the end point of the curve, assuming it's percentage, not magnitude. Clear? So the other thing it's going to ask for is a radius for each of the parameters. That's very, very important for each of the parameters. So I'm going to make 2 panels, and I'm going to make sure they're off of multi-line data. And I'm going to say 0 and 1. That's my list of parameters. And then I'm going to make another one, same number of items, but this one is going to be my radius for each of those parameters. So I'm going to start with something pretty large. I'm thinking, actually, how wide is my building base? All right, let's do 8 feet. It's probably going to be huge, but we'll start off with like an 8-foot base. Actually, that's really gigantic. Let's just do like a 5-foot base. And we'll go to a 2-foot with radius at the top. Plug that in, and this is what you get. You'll notice that they're actually wider up top than they are on the bottom. So the curve direction was reversed just based off of how I created my geometry. Yours might not be created that way. Yours might be smaller at the top and thicker at the bottom. It just depends on how it was created. So what I need to do is reverse all of these curves. And I think I can do it here. No, that just reverses the list, not the direction of the curve. So I'm going to go to curve, utility. I think it is here, right? Flip curve. There we go. I'm going to use flip curve. It just changes the direction of the curve. And I'll do that for each one of these. So plug that in, plug this in, plug that in, and plug this in. Then I can plug that into C, and it didn't work. Line like curve. 4 curves. Let's see if we graphed it. Now why didn't that work? That's super weird. All right, well, if that's not going to work, let's try flipping each one. And then plug them in the same way. And it's still not working. Recompute, maybe? No? Huh. That's super weird. Okay, hang on. Let me see if I can troubleshoot this. All right, guys. So it looks like I have absolutely no idea why that wasn't working. There's no reason that I can possibly think of that would prevent that function from operating as expected. But anyway, what I did as a fix is I figured maybe I can just reconstruct the curve. Maybe somehow the geometry of the curve just got corrupted, so I'll reconstruct it with a brand new curve. So I did that by using endpoints and then just flipping the start and end point and creating a new curve. And I'll show you how to do that here. Get rid of flip. So we go to curve and analysis, and this is going to help us read the endpoints. Plug that in there. Then you just go to curve primitive. We're going to create a line. And then you just plug the start point into B and the end point into A. And that creates your reversed curve. And then you can plug it in here. Okay, so that creates a little bit of a structure going back that way. And then you just do this for each one. Copy, paste, put it down here, paste down there, plug it in, and plug it in, and then plug these in. There. So now what you should have is a structure where the diameter of those columns are thicker at the bottom and thinner at the top. And you can change those too. All you need to do is just go back to these panels, and if for some reason you need it to be really, really large at the bottom, just change it. Something really thick, but that shouldn't be necessary. And you know, we're doing this really, we're doing this very diagrammatically. Something you'll need to consider in a real design is that you can't really have like a giant column like this and then have your truss structure kind of embedded into the base of it. You'll have to find a new base point to work off of, that kind of thing. So those are just things that you're going to have to consider as you get more skilled and more detailed with your model. But for now, we're just trying to understand the high-level principles. Let's go back down. Okay, so we've got some structure. That's these. We also have some secondary structure. That's these. And the next step is going to be to actually generate a facade. And then we're going to render it, sort of, kind of. Okay? What questions do you have? All right. This is what you need.